Hello everyone. After completing complete of CDN, now we are going to discuss a new topic in the same Cloudflare website. So without any further delay, let's see what is under our eyes today. Opening a new Firefox instance as well as opening our favorite notes editor slash code editor, and I was again developing the BioPay application. So never mind, let me switch the folders to the Cloudflare, where it was development Cloudflare. Yes. So guys, quick update. I have actually updated the Cloudflare notes and I have also posted it, but I haven't linked in all of my videos. So it will be still be a task that I would do today, tomorrow, or yesterday. So never mind. But the notes can be found on my GitHub profile. You can visit there and search for the repository from the same name, Cloudflare Harsh. Okay, and I will soon post it as a link in right in the description of my video. So don't worry about that too. Let's continue with our cloudflare.com resources, learning, and so the top three rows are have been covered. The DDoS attack, sorry, the top first row is being covered: DDoS attack, CDN, and DNS. Let's see what is there something to learn in web application security. Sounds like a very small topic. No, it's not that small. So it must be take 2 or 3 videos in order to get it. So never mind. We will, if it take 2 to 3 videos, I will certainly deliver it. And let's begin. So, web application security is a practice of protecting website applications and APIs from attack. It is a broad discipline, but its ultimate aims are keeping web application functioning smoothly, protecting business from cyber vandalism, data theft, unethical competition, and negative consequences. The nature of the internet exposes web application and API to attack from many locations and a various level of scale and complexity. As such, web application security encompasses a variety of strategy and cover many part of software supply chain. Some common web application security risks are: first, zero-day vulnerability. These are those kind of vulnerabilities which are just discovered and we haven't have a cure for it. Next is cross-site scripting, which is in short known as accesses, is a vulnerability that allows an attacker to inject client-side script into a web page in order to access important information directly, impersonate the user, or trick the user into revealing important information. We have seen in the JavaScript video that how much browser knows about you, and just by running some script, for example, if I open developer console, we can see that there's a console, and if I just write some JavaScript here or paste some JavaScript code here, uh, this website or the data that this browser stores, for example, the data is stored here, for example, the cache storage, or the cookies for where the login signatures are present, can be passed using the JavaScript, and this is a form of cross site scripting. Next is SQLi. SQL, also known as SQL, is a database, and the SQLi, I stands for injection, is a method in which an attacker exploits vulnerabilities in a way that database executes search query. Attackers use SQI to gain access to unauthorized information, modified or create new user permission, and otherwise manipulate or destroy sensitive data. And we will see how to protect from SQL injection. Actually, SQL injection, there's a very great example regarding the SQL injection by Network Chuck, from the same guy that who makes or who make me curious to get to know and hold of networking. So that's a great one. That's a great example. I will certainly try to imitate that example in our upcoming thing. Okay, so next is denial of service or distributed denial of service. We have covered almost everything of it. So it is targeted through various factor. Attackers are able to overload a targeted server and its surrounding infrastructure with different types of attack traffic. When server is no longer able to effectively process incoming request, it began to behave sluggish and eventually deny service to incoming request from legitimate users too. Next is memory corruption. The memory corruption occurs when a location in memory is unintentionally modified, resulting in the potential for unexpected behavior in the software. Bad actor will attempt to sniff out and exploit memory corruption through exploits such as code injection, buffer overflow. Okay. So next is buffer overflow itself. The buffer overflow is an anomaly. Anomaly means a fault that occurs when software writing data to a defined space in memory known as buffer. Overflowing the buffer capacity result in adjacent memory locations being overwritten with data. And this behavior can be exploited to inject malicious code into memory, potentially creating a vulnerability in the targeted machine. Next, cross-site request forgery (CSRF). Cross-site request forgery involves tricking a victim into making a request that utilizes their authentication or authorization by leveraging the account privilege of a user. An attacker is able to send a request masquerading as a user. Once a user account has been compromised, the attacker can exfiltrate, destroy, modify important information. Highly privileged accounts such as administrator, executives are commonly targeted. Next is credential stuffing. Attacker may use bots to quickly input large amount of stolen username and password combinations into a web application's login portal. If the credential stuffing gives attacker access to a real person's account, they may steal the user data or make fraudulent purchase in the user's name. Next is page scraping. The attackers may also use bots to steal the content from a web pages on a large scale. This may use this content to get pricing advantage over the competitor, imitate the page owner for malicious purpose or other reason. Next is API abuse. API, which stands for Application Programming Interface, are software that allows two applications to communicate with each other. So this is the language by which an web application communicates with another. Not necessarily web application, but any application communicates with other application. Like any type of software, they may have vulnerabilities that allow attacker to send malicious code into one of the applications that intercept sensitive data as it moves from one application to another. This is an increasingly common attack as the types of API increases. The OWASP API top 10 list succinctly summarize the key API security risk organizations face today. And continuing the API thing, next is shadow API. Their development team work quickly to make business objective, frequently building and publishing API without informing security teams. The unknown API that has not been informed to security teams expose sensitive company data too. Operating in the shadows of security team ask with protecting API that are unaware of their existence. Okay. Next is third party code abuse. Many modern web development or web application use a variety of third party tools. For example, an e-commerce site using a third party payment processing tool. If attacker find a vulnerability in one of these tools or the implementation of one of these tools, they may be able to compromise the tool, steal the data it process, preventing it from functioning and use it to inject malicious code elsewhere in the application. Make cart attack, which skim credit card data from the payment processor, are an example of this type of attack. These attacks are also considered to be a browser supply chain attack. Okay. And next, attack surface misconfiguration. An organization's attack surface is its entire IT footprint that could be susceptible to cyber attacks. Servers, devices, software as services, and cloud assets that are accessible from the internet are its attack surface. This attack surface can remain vulnerable to attack due to certain elements being overlooked or misconfigured. Now, some important web application security strategy. As mentioned, web application security is a broad and always changing discipline. Okay, so first is DDoS mitigation, next is web application firewall, third is API gateway, fourth is DNS SEC, next is encryption certificate management, next is bot management, next then client side security, and finally the attack surface management. Let's see or go through each one by one. So we know that how the DDoS can be mitigated. Okay, oh, very sorry. Yes, using a specialized filter and extremely high bandwidth capacity to prevent surges of malicious traffic. These services are important because modern DDoS attack are to overwhelm the most resilient server we know. Next is web application firewall, which filters out the traffic known or suspected to be taking advantage of web application vulnerability. Web application firewalls are important because new vulnerabilities emerge too quickly and quietly for nearly all organizations to catch on their own. So what it does, it automatically updates its definition and is far more spreaded than the physical firewall. Okay. Next, API gateway, which helps to identify the overlooked shadow API and block traffic from known or suspected to target API vulnerability. They also help to manage and monitor API traffic. Okay. Next is DNSSEC, a protocol which guarantees that a application's DNS traffic is safely routed to the correct server. So users are not intercepted by an on path taker. Okay. Next is encryption certificate management, in which a third party manages key element of a TSSL TLS encryption process, such as generating private keys, renewing certificate, and revoking certificate due to vulnerabilities. This removes the risk of those elements going overlooked and exposing private traffic. Okay, so we establish a third party, or we take an certificate from the granted third party, the SSL and TLS certificate, for generating private keys, renewing certificate, and revoking certificates due to vulnerability. Okay, and this risk hence go overlooked and exposing private traffic. Okay. Next is bot management, which uses machine learning and other specialized detection method to distinguish between automated traffic from human and to prevent the former from accessing a web application. Okay. Next is client side security, which checks for a new third party JavaScript dependencies and third party code changes, helping organization to catch malicious activity sooner. And finally, attack surface management. Actionable attack surface management tools should provide a single place to map your attack surface, identify potential security issues, and mitigate risk within few clicks. Okay. Next, web developers can design and build application in a way that prevent attack from accessing private data. Okay, and how it can be do? Uh, a SQL injection can be prevented by using some input validation, blocking improperly formatted data from passing through the application's workflow helps to prevent malicious code from entering the application via injection attack. Yes, using up to date encryption, storing user data in encrypted fashion may help, offering strong authentication and authorization. Okay, actually, we have some three vows of authentication and authorization. What some person is, what some person have, and what some person knows. I think these are three things. We will see that in the authentication and authorization separate articles. So keep that in mind. Next, keeping the track of API. Tools exist to identify shadow API that could constitute an attack surface, but new API security becomes easier when API never get unlocked in the first place. And finally, documenting the code changes. Okay. So if the developer uses comments, so normal people can also see what is being changed and why it has been changed. Okay. Let me exit the reading mode in order to. I just want to copy everything to here. Not everything, but the main topic. 0 day vulnerabilities. I don't know why, but I just want all here. Cross site scripting. Next is SQLI. Then denial of service. Then distributed denial of service. Dude. Next is memory corruption. Next is buffer overflow. Next is cross site scripting forgery. Next is credential stuffing. Next is page scrapping. Next is API abuse. And after that, there is shadow API. After that, we have third party code abuse. Okay. After that, we have attack surface misconfiguration. And here we have a strategies called DDoS mitigation, web application firewall. Let me do that quickly so you guys don't have to wait it. DDoS mitigation, web application firewalls, API gateway. But why I am doing this? I am doing this in order to keep an eye on everything, just for the sake of revision, because these only by looking after these things, everything can be everything regarding the article can be remembered. In a sec encryption, then we have bot management, and finally client side security, and finally attack surface management. Oh, and finally best practices are input validation, up to date encryption, strong authentication and authorization, tracking of API, and documentation. Okay, thank you guys. Time for API security. What is an API? So, API stands for Application Programming Interface. Is a set of rules that enables a software program to transmit data to another software program. API helps or enables a developer to avoid redundant work. Instead of building and rebuilding an application function that already exists, Developers can incorporate existing ones into their new application by formatting request as requires. An API is an interface, meaning a way of one thing to interact with another. As a real world example, an ATM has an interface, a screen and several buttons, allowing customer to interact with their bank and request services like getting cash. Similarly, an API is how one piece of software interact with another program to obtain needed services. For example, there is an example of website. So Jennifer builds a website that help consumers or commuters to check the highway traffic before they leave for work. Jennifer could spend a lot of time and money setting up complex highway tracking system to provide this information to website users. But these capabilities already exist, and outside parties have created such system. So instead of reinventing the wheel, Jennifer website uses an API that is offered by an external highway tracking system. Now Jennifer can focus on building other aspect of the website. Actually, we do have API for the Google Maps as well. So next, what is an API call? An API call, which is also known as API request, is a message directly aired as API that triggers the API's use. Referring back to example, Jennifer constructs her website in a way when it loads, it automatically generates an API call to highway tracking system. The response come back from the website from the service enable it to display the latest traffic information. Okay. Next, API calls have to be formatted in accordance with the API requirement in order to work. The API requirements are called its schema. A schema also describes the type of responses that are provided to each request. Suppose a computer uses Jennifer's website to check traffic on Highway 192. The website sends an API call to provide information. The message that reads Highway 192. The highways tracking system server API receives this message and replies with the travel times on 192. Imagine the API schema in this way. Okay. So we have an API request for Highway 192 and a response as travel times on this. We have some data. Then for 217 and 225, we have also the same thing. Now suppose the Jennifer's website sends an API request for highway ASDFG. This is not a valid request, and because it does not conform to an schema, which only allows for actual names, the server will not be able to provide a usable response. Next is an endpoint. An endpoint is the end of a communication channel. An API endpoint is the place where an API response originates from. Okay. In the example, the client of API connection is a Jennifer's website and the endpoint of the server that hosts the API. Okay. The Jennifer's API calls have to go through a certain URL. A URL, for example, there is a Cloudflare slash learning that uses the API server is responsible for in order to get the response. Okay. So what is API integration? The API integration is the combination of two or more applications using API. The API integration is what enables one application to benefit from the capabilities of another application. Just as combining a sales team and a marketing team in an office enables those two teams to work together and benefit from each other's effort. API integration are also commonly used for synchronizing data between two applications or databases. Let me tell you something. For example, you must have used an Android phone and every hardware components because the Android is an open source thing. You must have heard something about the camera API too. And previously we used the camera API, and now there's actually I don't know, but there must be a new version regarding that, new iteration. So what it does, it actually enables new capabilities of the same camera hardware that your device comes in. So API basically enables multiple new types of calls. For example, if you use new camera API on your Android phone, and I'm very sure that right now it up to this date, you must be using that, and which enables features like night mode, stabilization, etc. on a hardware level from the camera to your camera application. And this API thing is the reason Why is Android is still not able to provide its complete control over camera to the third party apps. Only a few device manufacturer, for example Samsung, uh, on the Android side, actually allows the other third party applications like Snapchat or Instagram to complete utilize their API. And it is one of the reason why Android cameras are good on their default camera app but not on their third party apps. For example Instagram, the picture seems blurry and does not utilize the complete API or capabilities that a camera offers. Okay, and moving on, there is a web API. So anything that involves computer code that can have an API. For example, the operating system or software libraries, web API is specifically used by web applications that are accessed over the internet. The web APIs are incredibly important for modern internet. Almost all user-facing applications rely on API to function. Not just Jennifer website, every website. Entire software development philosophy relies use on API. One such philosophy is Jamstack, with Jam standing for JavaScript, API, and markup. Another example is microservices architecture, which also uses API in order to call the different functions that make up an application. Even application built without these approaches usually rely on API. So APIs are everything. And then we have two kinds of SOAP API and REST API. Actually, it is a abbreviation for Simple Object Access Protocol. And I just have to copy it and paste it in our abbreviation section and make it bold. So, Simple Object Access Protocol. Okay, we have to do some few decorations here because this code has been already decorated by ChatGPT. Never mind. And then we have REST API, which stands for Representational State Transfer. So paste it here. Yes. So SOAP is a type of protocol. SOAP APIs and APIs are only use of SOAP protocol, while REST is an architectural style for web services. The REST API is any API built using REST architecture. Unlike SOAP APIs, REST API work with any protocol, and most APIs today are REST API. Do API introduce security risk? Just as allowing a person to use an application introduce the risk that the person will abuse the application. API do come with the same risk because an API client will or may abuse the service. Additionally, web API calls the travel over the internet and calls can be intercepted, spoofed or modified just like another data transferred over network. So API security, we have just already seen somewhere API security. Where API gateways. Okay. So to prevent the API abuse, we can use the API gateway. Okay. Okay. API security is a core component of web application security. And crucial API security measures include rate limiting, DDoS protection, authentication, schema validation. And we do have a Cloudflare API gateway that include these as well as other security features to protect the network against the API threat. That's a great thing. We already seen what's the rate limiting is, but if you're just curious, let me tell you as quickly as possible. The client who makes many API requests can slow down or crash the API for other clients. So rate limiting is putting a cap on the API request from a single endpoint within a certain time frame. Then we specifically knows what a DDoS protection is. If if multiple API requests are coming to the API owner may black hole the API request at once. Next is authentication. It is important to authenticate API endpoint and client in order to make sure API requests come from the legitimate source, not from attackers. Okay. And next is schema validation. If an API request does not conform to API schema, The API may react in unexpected ways by revealing confidential data, for instance. So schema validation enables an API to drop such requests. Okay. The thing that you've just seen when I opened my VS Code, it was a Bharat Pay web application, which is a SOP management kind of website. Actually, I modified the code not by myself. Certainly, I use the chat GPT, but I introduce some form of validation that you have to select some drop downs, some nested drop downs in order to get an output from the API. So it is a kind of API. For example, if I show how my Bharat Pay application works, so let me open it. Bharat Pay Dev. No, it was I think Bharat Pay. Bharat Pay Assets, Bharat Pay Neo. I think Neo was the updated application. I guess yes. So there is lots of data, lots of functions. So what it inherently does, because if you can visit this website, it is not currently in updated state. It's actually the updates are actually hidden from the raw internet, but you can certainly visit this if you are able to see using this latest application. Actually, the data file is stored in bharatpay.json. Okay, and this is a function that creates a drop down, and unless a specific kind of drop down is selected by using the uh, what to say, let me show you the data. It has something set as output true and false. If only the output becomes true, then only the data gets outputted to a div. Div is a container in the website. For example, everything that you see on a website is stored inside of a div. So this section is called a div. Actually, you can use the extension like pesticide to see what are the divs. So here every blue box is called a div. So this website is actually built on a div set network or div sets. Okay, never mind. So I just want to tell you the description how and actually how I built my website. And let's back to our Cloudflare section. Next, how do API work? Okay. So API allows software to communicate. We know that what it does. And what is an API? API is an interface. We also know that. What is an API client? API client, sometimes called an user, is a software that initiates the API call. Okay. Typically, authentication is carried one of the four methods: a unique string, a username or password combination, a OAuth token, or a mutual TLS. By using a strong authentication method, one of the ways developer can safeguard API from attacks. Okay. Next is API endpoint. An API endpoint accepts the API call and returns the requested information. Both API clients and endpoints refer to the software program hosted on the server rather than the discrete hardware devices. The API server may host multiple endpoints, okay, allowing it to be located by an API client. For most use cases, this URL or URI, Uniform Resource Locator, or URI stands for Uniform Resource Identifier, which points to internet based location, for example, a website. Then what is an API schema? The API schema is the metadata that defines the specification of an API request must meet in order to be considered valid. These specifications may include details including the target endpoint, HTTP method, and other requirements established by developer. When an API call is sent from a client, it must meet the condition outlined. Okay, where we were? Yes, only then an API endpoint can return the requested information. To put this into perspective, imagine Bob is planning a party. On invitation, he specifies only guests who bring yellow daisies will be given thank you card after the party. If, however, Carol decides to bring red roses, she will not receive a thank you card afterward. Okay, so API do have requirements, and requirements has to be filled by the client. And what is an API? Let's see how it actually works. The API client initiates the API call or request for the information. The API endpoint receives the request. The API endpoint then authenticates the API client and validates the API schema. The API endpoint returns the requested information to API client. Okay. The API schema determines the type of response that may be returned to the client. Okay, so the API schema simply determines the type of response. Okay, so we will go into more depth in the next article, which is what is an API call and what protocols and architectures do API use. So the most two API protocols, common protocols are SOAP, Simple Object Access Protocol, and next is REST, Representational State Transfer, and there is another one, RPC, Remote Procedural Call, and it is a software architecture which often compared to these protocols. SOAP provides a standardized method of sending and receiving calls between API using different operating system. It is compatible with HTTP, FTP, SMTP, and other software application layer protocols, and only return the data to API calls using XML. Okay. RPC is one of the simplest and oldest method of communication between API. It works by initiating remote procedural calls, during which client request and a function from a remote server. The primary difference between RPC and REST is RPC helps to perform specific action, while SOAP or REST is used to retrieve resources. Okay. And finally, we have REST API, which stands for Representational State Transfer, which partially dictates how API calls are formatted. Put simply, REST allows a client or to request resources from a server, which returns the information to the client in its current state. REST API often use the HTTP protocol to format requests and responses, but are compatible with the FTP, file transfer protocol, SMTP, simple mail transfer protocol, and others. They can return data to API clients using different formats, including XML, extensible markup language, JSON file, JavaScript object notation, and HTML, hypertext markup language. Are API vulnerable to security risk? Yes. And these are the kind of attack that APIs are vulnerable. First is authentication based attack. Next is a vulnerability exploit, and third is DDoS attack. So we already and बहुत very eagerly knows what an DDoS attack is and how it occurs. Let's focus on the other two one. The authentication is a critical part of ensuring that API calls are sent and received from the legitimate sources. However, attacker can still bypass these measures to carry out attack, either by intercepting the authentication token, stealing API keys, or using other tactics to obtain confidential credentials. Next is vulnerability exploit. API vulnerabilities such as broken object level authorization, broken user authentication, excessive data exposure, and other, for example, from this list, refers to the flaws in API that may allow the attacker to access them without permission. By exploiting these flaws, attackers can carry out breaches or use API to launch complex attacks. Okay, PGP hijacking, border gateway protocol hijacking. And what is an API call? API call, which stands for Application Programming Interface Call, are a way for one program to interact with another. API calls are the medium which they interact. An API call or API request is a message sent to a server asking an API to provide a service of information. If Jan is hosting a lot of guests for dinner, she might call a catering company that asks to prepare food for the party. This saves her a great deal of time and effort preparing herself. Similarly, one application can call another for needed data or functionality. This ensures developers do not have to spend time and effort building application capabilities that can simply be integrated via API. For example, as the web is becoming more and more modular, everything is broken down into functions. If you have a developer role in the past, you can know the importance of function. For example, printing something, you don't have to write a print. You can just pass it within a parameter of a function, and the function will automatically decorate it. Uh, and this same approach of breaking the long chore of code into smaller functions is like API. You don't have to build a lot of things by oneself. You just have to pass some values to a function, and the function will automatically decorate it and pass it to another one. And because these functions or these APIs are integrated into almost all web applications, API calls can take place behind scenes all time. Suppose someone searches for the bus ticket on a travel website. The travel website sends an API call to various bus company servers and receive back information about what user rights are available, how much they cost. So they are everywhere. Every single application you can think of. It is communicating via the Android system via API. It is communicating its web server via API. So everything is on based on API. And API calls travel from a client to an endpoint. The API endpoints are the places that the API calls go. Most often, a web application and a server, mobile client, for example, generates an API call that go to API endpoint, a server. A server receives the API call, process it, executes the resource or request, and sends a response. When Jan, from the analogy above, calls the catering company, she does by dialing a phone number. Similarly, an API calls are directed at a URI. A URI is a standardized way or to identify a resource. Just as a phone number identifies a phone line, the identified resource could be a website, an application, a server, an email contact, or even real world item. For web APIs, the typical URI or web URL or URI is an identifying internet location like a website or a server. A URL has to include the application layer protocol, for example, HTTP, used to reach it. The website address are written as HTTPS. S stands for security because it uses SSL or TLS, then cloudflare.com/learning. API endpoints are URL too. So most web API uses HTTP that is included in the API endpoints URL. For example, the basic Cloudflare API endpoint is okay. Let's try visiting this. Let's see where it will lead us to. And yes, the actually we get the data in the JSON format. Success equal to false, error equal to 0, and message is no route for that URI. And the message is an empty array and result is null. Okay. So who HTTP based API calls uses the HTTP verb type of request, and HTTP verbs are get, post, put to denote what service or resource they need to get from that API endpoint. Like anything exposed to the internet, API are vulnerable to attacks from the variety of sources. These attacks are again DDoS or DOS attacks. Next is vulnerability exploits. For example, flaw in the authentication authorization are called vulnerability exploits. Next, how to secure API and from invalid API. Understand and track the API endpoint, verify API clients, validate API schema, and finally, DDoS mitigation techniques. By making sure that the requests are coming from a legitimate client. Next is like rules for if API calls does not follow the schema, it may be malicious attempt to exploit the API. Okay, must have to follow the schema, and finally the DDoS mitigation. We already know a lot about it. Next is what is an API endpoint. So I think this will be the last article that I'm reading in this video because I have to go somewhere. So see you guys next time. But let's finish this article first. It will take 5 to 6 minutes as directed. An application programming interface is in a way application to request a service from another application. We already know that. API servers. APIs are hosted on one or more servers, specialized computers that store data and execute software programs. Each server serves data, content, and software functionalities to other devices over the internet. An API endpoint is always hosted on a server. The other end of the API connection is API client, the entity requesting services from the API. Some call this the API user, even though the most of the API calls are automated. Okay. How does the API client know the server's endpoint? To be usable, the API has to be have documentation. The documentation indicates, among other things, what types of requests that API will accept and API can do. Okay, so the Cloudflare has an API documentation over here. So let me copy this, paste it. Let's see where it will lead to. Let it load. Yes, we have an API key. API key. So, welcome to the Cloudflare's API documentation website. Let me zoom it. We are experimenting with an updated version of API document. Check out to test the new experience. Okay. To get started using Cloudflare product and service via API, refer to how to interact with Cloudflare with tools like Terraform and official SDK to maintain your Cloudflare resources. Okay. Okay. Good. How do API uses URL? So the URL are used for multiple purpose, including locating website, which I do on a daily basis. The browser knows where to find a web page and how can it load it. URL are also used to indicate API endpoint. When Alice and Bob talk in the phone, the Alice calls Bob and Bob's phone number. Similarly, an API endpoint URL is like a phone number for making API calls. An API server can host one or multiple API endpoints, meaning it will accept and process calls from directed as these endpoints. So API client also need to have URL so that the API server knows where to send its reply. Just as Bob and Alice both need a phone number between them to in order to phone calls to be worked. Developers set this URL when building an application. um, in my full stack journey, what I have seen that we use the applications when we were developing the backend for an application. We used express.js, the JavaScript library, for building such endpoints. So the front end framework can call to that in order to get the data from the database. Okay. So how do API endpoint and client authenticates? And properly designed API does not accept API calls from just anybody. This would leave the API server to receiving malicious data from the attacker. So we have an example to test the API, and this is called. So we have an application, and this is called the Postman, and it requires sign in. So without sign in, it won't load. So Postman is an application that tests an API using all the four methods or all the multiple, what to say, the HTTP, what it was, HTTP methods. No, it was something that I've just read in the article. The get, post, put, delete, etc. So authentication is the process of verifying an identity. So we can put the verifying parameters via Postman when making an API request. So it would be put in the API forwarded API calls with as a encapsulated header. Okay. So there are four main ways the API endpoint can enforce an authentication. The API client is assigned a key or a unique string of characters that only they and API service know. When the API client sends an API call to server endpoint, it includes the key so that the server knows very well where the calls come from. Next is basic authentication. Similar to the key approach, the API client sets up a username and password with API service. It includes these credentials in the API call. Okay. OAuth token. Okay. So we have instead of requiring authentication from a client, the API server can get authentication token from a trusted authentication server using OAuth protocol. And finally, we have manual TLS. So the TLS is a protocol that creates an authenticated connection between client and server when loading web pages. In many cases, mutual TLS is the most effective authentication method. For one more thing, it authenticates both endpoint and client, not just the client. So both sides can be sure that they are receiving data from a legitimate source. It also uses the private key, which are never shared between endpoints and therefore cannot be intercepted in the transit. On the other hand, API keys, password, tokens, all can be duplicated or stolen. So API shells use mutual TLS to authenticate API endpoints and client, helping protect both sides from an attack. The API shells also offer several other API security features. For example, a rate limiting, data loss prevention (DLP), and you can learn about the shield in the Cloudflare articles or in this article. So we will see that too. So thank you guys. Thank you for all of this that you joined me today. And due to some urgency, I have to stream. I have to end the stream 10 minutes early. But never mind. We will join it again. Thank you.